Kia ora koutou. I'm going to start videoing this year's school exams for Level 3 Calculus, and I'm starting with one of the excellence questions in the differentiation paper. So this was a question with quite a bit of tricky, just kind of messy algebra, where we had to find the second derivative for an equation that was given to us in parametric terms. Things to watch out for in here are negative powers and fractional powers, and just trying to do some good, neat working so that we don't make small errors. So we start off with x is equal to e to the negative 5t squared. I'm just going to change the pen colour. And y is equal to root t. So I'm straight away going to write that as t to the power of a half. So the first step when we're working with parametric functions is to differentiate with respect to t and then to use the chain rule. So we start off with dx by dt is equal to negative 10t times e to the negative 5t squared. And dy by dt will be 1/2 t to the negative 1/2. Now, as usual, we find the first derivative, dy by dx, by using the chain rule. It'll be dy by dt times dt by dx, which is the same as, we can write that as y dash divided by x dash, right? So we don't have this derivative, but we do have its reciprocal, which is dx by dt. But if you're watching this video, hopefully you know that, and this should be feeling pretty easy. So this was I think the achieved part of the question. Right, so putting this together, we've got 1/2 root t divided by dx by dt. So divided by negative 10t e to the negative 5t squared. Now, cleaning that up, what do we get? Well, I'm going to go back to fractional powers here. I've got 1/2 t to the power of a half times negative 1/10 of t e to the negative 5t squared, right? And I'm going to rearrange that and get negative 1/20. Now, carefully combining the t's, I've got t to the power of a half here and t here. So that gives me t to the negative 3/2. And I've got e to the negative 5t squared, but in the denominator, so that's equal to e to the 5t squared. Okay, so far so good. So that's dy by dx. Now, to find the second derivative, what we want to do is we want to differentiate dy by dx with respect to x. But we can't do that because, well, we can't do it directly because this is in terms of t. So what we can do is differentiate this with respect to t and then use the chain rule to get me out of the mess, right? So times by dt by dx. And to differentiate this, we're going to need to use the product rule, but it's not too bad, and we've already got this from up above. So all we need to do is to just go quite slowly through the next bit of working. You can write this out if you want to with UV notation. I would just keep that negative 1/20 with that bit and then have this as your other bit, but it doesn't really matter. Someone in class said, could you just put the negative 1/20 at the front? And yes, you could definitely do that. Right, so let's just start by saying what's the derivative with respect to t. Okay, so by the product rule, we're going to have negative 1/20 times negative 3/2 t to the negative 5/2. So that's the derivative of the first bit. So that's u dash times v, e to the 5t squared. And now the other way around, right? Plus negative 1/20 t to the negative 3/2 times the derivative of this, which is going to be 10t e to the 5t squared. So I'm just going to shrink that a little bit so you can see it. Okay, so far so good, but I want to clean that up before I go any further. We get 3/40, 3/40 of t to the negative 5/2 times e to the 5t squared minus 1/2 t. I've got this t here and this one here. So adding those powers gets me t to the negative 1/2 e to the 5t squared. We know that we're setting it to 0, so we kind of should know that we're heading towards factorising. So at this stage, I'm going to take out e to the 5t squared as a common factor, and I'll have 3 over 40 t to the 5 over 2 minus 1/2 t to the 1/2. So the last thing we've got to do is to multiply this by dt by dx. So d squared y by dx squared will equal this. And now I'm going to times it by dt by dx, which is 1 over negative 10t e to the negative 5t squared. Right? And this comes from the work we did earlier. Right, now we're asked to figure out where that's equal to 0. So e to the 5t squared over negative 10t e to the negative 5t squared is equal to e to the 10t squared over negative 10t, and that's not equal to 0 anywhere, right, because this is always positive. And that means that the only part that's going to make this second derivative 0 is when this is 0. So we need to have 3 over 40 t to the 5 over 2 is equal to 1 over 2t to the half. Cleaning that up, let's have a look at what we get. Well, we get 6, what am I doing here? 6t to the 1/2. This is not exactly how I did it when I was doing my working, but that's okay, is equal to that. And I'm going to, what am I going to do with that? Oh, that really isn't how I did it before. Okay, you know what, guys, I'll do this 2 ways. First, I'm going to do it the nicer way that I did it when I was washing through my working before I made this video. And what I did with this step is I just took this factor and got it into a common denominator. So 3 over 40t to the 5 over 2 minus 1 over 2t to the 1/2 is equal to having a common denominator of 40t to the 5 over 2. So I've just got 3 here. I don't need to do anything there. And here I've got to times the 2 by 20. And then I've got to times it again by t squared. And that makes it really clear where we're going. So that means that we have to find when that is equal to 0. And the only time that that's going to equal 0 is when the numerator equals 0. So we get 3 minus 20t squared is equal to 0. T squared is equal to 3/20, which is 0.15. And t is equal to the positive or negative square root of 0.15. Now, I actually can't remember what that number is. I'm just going to go and check and be back in a second. Okay, so I went and had a look, and it's equal to, t is equal to plus or minus, I think it was 0.3873. Now, I think that's the number I just looked at, but I've already forgotten it. So I think that's the cleanest way to do it, right? You've got a really clearly laid out second derivative here. And the only way you're going to get that equaling 0 is if that middle term equals 0. And we've made that clear in this step here. The working I was starting to do before, I'm actually not sure if anyone's still watching, was just to work with this and set this equal to 0 and not get a common denominator. So now what I'm doing is I'm solving it like this. Obviously, these are the same thing. It's just that it's to show you that we end up with slightly different manipulation here. So we get 6t to the 1/2 is equal to 40t to the 5 over 2. And I can simplify that and get 3/20. And now we know, do we know that t is not equal to 0? Yes, we do know that t is not equal to 0 because it's in the bottom line of a fraction. And that means that I can divide through by the square root of t. So 3 is equal to 20t to the 5 over 2 over t to the half. So now I get 3 is equal to 20t squared, and I can go from there. Okay, so a pretty similar process, and there are different ways to do it. And as I said in class, if we go all the way back to the start, when we come to do the second derivative, let's just have a look at what we've got. We could do it with the quotient rule, but I think it's going to be a whole lot more work. So if we were using the quotient rule here, we'd start with negative e to the 5t squared divided by 20t to the 3 over 2. Right, so that wasn't my preferred method. The quotient rule for me is usually messier, but I know that some of you, I think, did get there or got pretty close doing it that way. I guess the biggest thing to watch out for with this is that it's this idea that when we're differentiating and finding a second derivative, when it's parametric, that we're always going to have to do the chain rule on it, right? Because we're never going to be able to differentiate directly with respect to x. But by this stage, you should be pretty comfortable with differentiating with respect to one variable and then using the link between the other two variables to use the chain rule and figure it out like that. All right, thanks for watching. If you're in 13 MCA, the existence of this video probably tells you that I'm going quite well with the marking. I'm just about finished the whole paper, and I will let you know when the results are ready to go up.